The purpose of this video is to explain a little bit more about voltage division, and in order to do that, you may have seen the other voltage division video in this playlist, Mysteries and Musings. This particular situation occurs in Chapter 5 of Teach Yourself Electricity and Electronics, 5th edition. That's edition number 5. It is in Chapter 5. It is quiz question number 18. You'll find it on page 88 if you have the printed book, and here's how it reads. Refer to figure 5-7 on page 82. I'll bring that up in a minute. Suppose the battery voltage equals 18 volts. The network contains 4 resistances, and we want to obtain intermediate voltages of 4.5, 9.0, 13.5 volts. We want to design the circuit to draw a constant current of 500 milliamps from the battery. What ohmic values should we use for the individual resistors? And if you'll go to the answer key after you've worked the problem out, in case you haven't been able to figure it out for yourself, we should set all 4 resistances at 9.0 ohms. There's a couple of ways that you can arrive at that answer by a process of elimination. That's one way to take a test. You can simply check out B, C, and D, actually make the calculations and see if any of them work, and if you do that, you'll find that choice D actually works. That's one way to do it, and then you can rule out choice A because you obviously have been able to arrive at an answer without having to know the amount of power that each resistor will dissipate. Although that does come into the picture, that is a consideration in a situation when you have a voltage divider network, because if you make the resistances a certain value and you don't have a sufficient amount of power dissipation capability, you'll burn the resistors out. But here's figure 5-7, which you'll find on page 82, and in this particular situation we only have 4 resistances, so this little gap here, you can consider that to be shorted out and to be irrelevant. The reason that I put that there in figure 5-7 is in case you need to have a whole lot of resistors or an indeterminate number. This just means there might or might not be anything in there. But anyway, we have R sub 1, R sub 2, R sub 3, and R sub 4. And then, of course, we have voltages E sub 1, E sub 2, E sub 3, and E sub 4 that we can get across one resistor, just R1 all by itself, or the series combination of R1 and R2, that's the E2, E sub 2. The combination of R sub 1, R sub 2, R sub 3 in series will give us voltage number 3, and then the voltage across the whole thing is going to be the same as the battery voltage, and we are told that the battery voltage here, 18 volts. And then we're told what these actual voltages that we want are. We are also told that this entire network is supposed to draw 500 milliamperes of current. Well, 500 milliamperes, as you may be able to figure out, is 0.500 amperes, or exactly a half an amp. So if we use Ohm's law, we can figure out what the total resistance here should be. The total resistance R should equal E divided by I. That's going to be 18 divided by 0.500, which is simply 18 times 2, or 36 ohms for the entire combination of resistors in series. Well, you can go back to the choices here and look at the B and C If you add all those values up, you're not going to get 36 ohms, so you can rule that out, B and C out right away. You can go to choice D, 4 resistances at 9.0 ohms. Well, okay, that looks pretty good. 9.0 ohms, 4 of them, 36 ohms. And it draws 500 milliamps. So all we need to do now is figure out what in fact these intermediary voltages will be. Remember, the voltage equals the current times the resistance. According to Ohm's law, if you have a resistor carrying a certain amount of current, then the voltage across that resistor is going to be that current times its resistance. All right, we've got 4 resistances. Each one of them is 9.0 ohms. We need to test out and see if choice D is actually going to give us the voltages that we want. Okay, so here we have right here 9.0 ohms times 1/2 of an ampere. Well, I think you can probably do that in your head. Figure out that's going to be 4.5 volts. Well, that's voltage E sub 1, 4.5 volts right there. That's what we want. Now R sub 2 and R sub 3 and R sub 4 are also 9 ohms each, 9.0 ohms. So each one of these resistors is going to have a voltage of 4.5 volts across it. So we have these two voltages in series. That's going to give us 9.0 volts for E sub 2. That checks out. 4.5 plus 4.5 plus 4.5 is 13.5 volts at E sub 3. That checks out. So it all checks out, and choice D, therefore, is the correct answer to this question. Now, we need to keep in mind that this is only going to work provided that what we put across these points doesn't load the circuit down and change any one of these resistances significantly. If it does, then we're going to have a problem. Each one of these resistances, remember now, is 9 ohms, 9.0 ohms. If we put a 1,000 ohm load across here, it's not going to significantly alter the 9.0 ohms or 18 or 27 ohms. So we can put 1,000 ohm loads across here and we're okay. But if we put, say, a 6 ohm load across this 9 ohm resistor, or to make it more simple, a 9 ohm load across the 9 ohm resistor, we're going to change this R sub 1 all the way down to 4.5 ohms, and that's going to throw off the entire voltage divider network. So it's important when you design a voltage divider to keep these resistances a lot lower than you expect the loads across them to be. Otherwise, you're not going to get the values that you're hoping for. The other problem that you need to watch out for is if you make these resistance values quite low, you're going to have to make certain that you make the resistors robust enough so that they can withstand the power that they're going to be called upon to dissipate. In this case, for example, we have 9.0 ohms and a current of 0.5 amperes. So we have 0.5 amperes and we have 9.0 ohms. Remember that the power that one of these resistors then will dissipate is going to be I squared times R. Well, 0.5 squared is 0.25 times 9.0 is going to give us 2.25 watts. Each one of these resistors then is going to have to be capable of dissipating 2.25 watts. Otherwise, we're going to get a situation if we use 1 watt resistors here, they're going to burn out. They're going to get hot. You're going to watch them get red, and they're going to burn out. You don't want that. So you're going to need to make sure when you design a voltage divider like this that you have resistors that can withstand the power. If these resistors have different values, the situation gets more complicated. One of them may hog the voltage and have a tendency to burn out a lot more easy than the other ones do. So once again, the correct answer to this quiz question is choice D. We should set all 4 resistances at 9.0 ohms, keeping in mind that we don't want to load any of them down to cause the values to significantly change. As long as we do that, we'll get a voltage divider circuit that works.